Okay, we're continuing on with writing equations from information. You might remember that the general idea was we're writing equations given all kinds of different things. If I give you a graph, if I give you a point and a slope, or if I give you 2 points, and we're still on this right here, the 2 points, but I want to point out something that sometimes happens, and that is, what if the lines are horizontal or vertical? Now, I grant you, that doesn't happen a lot. Okay, so if you're looking at our context of a tricycle racer, yep, you could have a person that starts at 20 feet or just a little bit behind it, and then doesn't go anywhere. So there they are. 16 seconds later, they're still at 20 feet. I don't know what happened, but yeah, that could go on, I suppose. But I recognize that the whole idea of this happening is pretty dang unlikely. Let me change colors to that so it looks a little bit different. So how's that going to happen? At 8 seconds, they were at 4 feet and 8 feet and 12 feet and 24 feet. This is ridiculous. Okay, so in lots of contexts, a vertical line doesn't make any sense. Okay, there are some where maybe you're doing a drawing and you're using digital artwork to create that, and you need an equation, but in lots of contexts, it doesn't make sense. But I do want you to see how to do this. Okay, so what I'm going to do is take you back to what we've been doing before for just regular ones. So this one here, I've got 2 points that the line's going through. I'm supposed to find the equation of the line that goes through it. And as you know, we've been having it look like this. Where the number in front of x is always the slope and the number out here is always the y-intercept. And what we'd been doing was finding the slope first, and we said, first let's subtract the x coordinates, and I don't know what direction you want to go. I'm just going to go ahead and go 1 minus 4. Sorry, that's the y coordinate. Subtract the y coordinates first. 1 minus 4, that gets you the rise. Okay, my silly way to remember it is subtracting the y's gets you the rise. To get the run, I'll subtract the other ones. So I went left minus right, so I'm going to go left minus right. I've got a lot of minus signs and negative signs hanging around, so I've got to be a little careful here. This is going to be a negative 3 up top here. And negative 2 minus negative 8 is the same thing as negative 2 plus 8, so 6. And this whole thing reduces down to negative 1/2. Okay, so that is what goes here. So here's my equation so far. Y equals negative 1/2 x plus something. And then the technique we've been using is saying, look, let's just pick one of the points. It doesn't matter which one. And if I put negative 2 into my equation when I'm all said and done and calculate all this stuff, I have to get 1. So I'm going to put a negative 2 in for x and then ask myself, what do I have to have in that box in order to get to 1? Now, I could do the exact same thing using a negative 8 for x and a 4 for y. It doesn't matter which one I use. So negative 1/2 times negative 2, negative times negative is positive, half of 2 is 1, so I get 1. And what are you going to add on to 1 in order to get to 1? Well, 0. So you could put a plus 0 at the end of the equation. It looks kind of silly. Or you could just say, look, y equals negative 1/2 x. So we've been doing that. If I look at this one here, same idea. Let me just go 6 minus 2 is 4, and negative 5 minus 5 is negative 10. So I end up with negative 2/5 as my slope. And then if I write y equals negative 2/5 x plus something, and I'll just go ahead and pick this one here. If I put a negative 5 in for x, whoops, blew that, put a negative 5 in for x, and ask myself, what am I going to have to add on to that in order to get to 6? Well, negative times a negative is positive. Let's see, 1/5 of 5 is 1, so 2 of them ought to be 2. What am I going to add on to 2 in order to get to 6? Well, 4. So when it's all said and done, I'm going to have a 4 there. Y equals negative 2/5 x plus 4. Well, what happens when you get to something like this? You'll notice that when I subtract the y's, I get 0. And when I subtract the x's, let's see, 7 minus negative 5 is 12. And so I got 0. So here's my equation so far. Y equals 0x plus something. Well, we can do the same thing. We could just say, look, if I put 7 in for x here, wow, I screwed that up. There should be a 0 right here, not a box. Okay. If I put 7 in there, what's 0 times 7? Well, 0. Okay. When it's all said and done, I'm supposed to get 4 for y. So what are you going to add on to 0 to get to 4? 4. So you get y equals 0x plus 4. And you might be thinking, well, come on now. 0 times x is just 0. So you could write 0 plus 4. Or that looks kind of silly as well. You could just write y equals 4. Okay. So what we did was the same kind of thing, and so if you get one that looks like this, if you subtract the y's, let's see, -1 minus -1 is 0. -4 minus 6, that's -10. Any way you slice it, you still get 0. So y equals 0x plus something. And if I choose one of these points, how about this one here? If I put 6 in there, 0 times 6 plus something has to get me to -1. Well, look, 0 times 6 is 0. So what are you going to add on to 0 to get to -1? -1. So I ended up with y equals -1. Well, you might have noticed something here. In this case, in the first one, not the first one, the one we just did, both y's were 4, okay, and we ended up with y equals 4. On this one, both y's were -1, and we ended up with -1. And it turns out it works exactly that way. If you looked on the graph for something like this, this one, the the red one, would be y equals 20. You could pick any 2 points on here and do the same process we did, or just say, look, the y coordinate on any point along here is 20. So y equals 20. So one option when you're looking at that is saying, look, whatever if the y coordinate is the same in both cases, then you just get y equals that number. So what's going to happen here? I can use what I just learned to say, hey, you know, if y is going to be 5 in both places, it's going to give me a slope of 0, so I know I'm going to end up with just y equals 5, and I'm done. Okay, so we're looking at this and saying, look, the y coordinate's always 5 because it's horizontal, and so we'll just say y equals 5. Well, that helps us answer questions like this. On this one, if I try to go through the whole slope thing, if I say, all right, the rise is -4 minus 8, and the run is 3 minus 3, you end up with -12 over 0, and your brain should go, oh, wait, red flag, you can't divide by 0. Okay, so we ended up with an undefined slope. We can't continue using the same strategy we had before, but we can say, look, I noticed that the x is always 3, so the equation is just going to be x equals 3. So on this one, I'd end up with the same problem, because when I try to do the run, 2 minus 2 is 0, I'd be dividing by 0, which is undefined. Can't do that. So we'll use that strategy that says, hey, you know, x is 2 every time, so the equation must be x equals 2. Okay. So we can use that pattern to make it go faster. When you see that the two y coordinates are the same, okay, then the equation must be y equals that number. When you see that the two x coordinates are the same, it must be x equals that number. So when you're doing an assignment like this and you end up with the normal ones that we've been doing, you go through the process and find the equation. If you end up with the y coordinates being the same, it's going to be y equals that number. If you end up with the x coordinates being the same, it's going to be x equals that number. So that helps you get through some of those things just a little faster. All right, hope that helps.